In today's episode, you will learn how to measure the soil nutrient content like nitrogen, phosphorus and potassium using the most accurate, fast and stable soil NPK sensor, Arduino Nano, I2C supported OLED display module, HC05 or HC06 Bluetooth module, and an Android cell phone application designed in Android Studio. You know all growing plants need 17 essential elements to grow to their full genetic potential. Of these 17 elements, 14 are absorbed by plants through soil, while the remaining 3 come from air and water. Nitrogen, phosphorus and potassium are, in short, NPK, or the big 3 primary nutrients in commercial fertilizers. Each of these fundamental nutrients plays a key role in plant nutrition. Nitrogen, phosphorus and potassium are really important to soil because nitrogen is used by plants for lots of leaf growth and good green color. Phosphorus is used by plants to help form new roots, make seeds, fruits and flowers, while potassium helps plants make strong stems and keep growing fast. A certain level of soil nutrients like nitrogen, phosphorus and potassium should be maintained in the soil, which is only possible if you know how to measure these 3 elements. Let's take the corn plant as an example. This is what happens to the corn leaves when the nitrogen, phosphorus and potassium nutrients are less in the soil. On the other hand, if you add more nitrogen, your plants may look lush and green, but their ability to fruit and flower will be greatly reduced. If you add more phosphorus, this will reduce the plant's ability to take up required micronutrients, particularly iron and zinc. This causes the plants to grow poorly and even die. The same thing happens when you add too much potassium in the soil. This disrupts the uptake of other important nutrients such as calcium, nitrogen and magnesium. So now you understand the excess and deficiency of these 3 elements is not good for the plants. So before you are planning to add the fertilizer, first take a few samples and check the nitrogen, phosphorus and potassium level using the soil NPK sensor. For the initial tests, we did temporary connections on the breadboard. First, we started with the OLED display module and displayed the nitrogen, phosphorus and potassium values on the OLED display module. After performing the initial tests and once satisfied with the values, then we started with the HC05 Bluetooth module and displayed the NPK values on the Android cell phone application. You can also connect the OLED display module. This way you can monitor the NPK values both on the OLED display module and also on the Android cell phone application. So anyhow, now you know exactly what you are going to learn after watching this video. Without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. This is the soil NPK sensor, N for the nitrogen, P for the phosphorus and K for the potassium. So this is basically the soil nitrogen, phosphorus and potassium 3-in-1 fertility sensor, which is used for detecting the content of nitrogen, phosphorus and potassium in the soil. This soil NPK sensor is considered to be the most high precision, accurate with accuracy up to ±2%, fast speed measurement and with increased stability. The resolution of this soil NPK sensor is up to 1 milligrams per kg or 1 milligram per liter. This is an easy to carry sensor and can even be used by non-professionals. All you need is insert these stainless steel rods into the soil and read the soil content. So the soil NPK sensor gives the user an accurate understanding of the soil fertility status. Thus the user can measure the soil condition at any time, and then according to the soil condition, the soil fertility can be balanced to achieve a suitable growth environment for the plants. This soil NPK sensor is provided with such high quality stainless steel probes which are completely rust resistant, electrolytic resistant, salt and alkali corrosion resistant. Therefore, this soil NPK sensor is suitable for all kinds of soil. Another feature that I really like is its ability to detect alkaline soil, acid soil, substrate soil, seedling bed soil and coconut brain soil. Moreover, this soil NPK sensor is IP68 grade waterproof and dustproof to ensure the normal operation of components for a long time. The soil NPK sensor has a total of 4 wires. Brown wire is the VCC wire and it should be connected with 9 volt to 24 volt DC power supply. The black wire is the ground wire and it should be connected with the Arduino's ground. The remaining 2 wires, which are the blue and yellow wires, these are the B and A wires, and these 2 wires should be connected with the B and A pins of the MAX 485 Modbus module, which I will explain in a minute. So you will need 9 to 24 volt DC to power up this soil NPK sensor. The NPK sensor supports 2400, 4800 and 9600 baud rates, due to which it can be used with different microcontroller boards like 8051 family of microcontrollers, PIC microcontrollers, Arduino boards and so on. In this tutorial, I will use the soil NPK sensor with the Arduino board. The soil NPK sensor is provided with a Modbus communication port RS485, due to which it can be easily interfaced with the Arduino board using the Modbus module like MIX 485 or RS485 module. The working temperature is from 5 to 45 Celsius. The nitrogen, phosphorus and potassium resolution is 1 milligrams per kg or 1 milligram per liter. The measuring range of the soil NPK sensor is 0 to 1999 milligrams per kg, and the working humidity is from 5 to 95%. The maximum power consumption is less than or equal to 0.15 watt. This is the MAX 485 TTL to RS485 interface module, which is used to connect the soil NPK sensor with the Arduino, as this interface module can be easily powered up using the Arduino's 5 volts. The MAX 485 interface module is ideal for serial communication over long distance of up to 1200 meters or in electrically noisy environments. This is the reason it is commonly used in industrial environments. It supports up to 2.5 megabit per second data rates, but as the distance increases, the maximum data rate that can be supported comes down. The RS485 has the ability to communicate with multiple devices up to 32 on the same bus or cable when used in master and slave configuration. I have already written a detailed article on how to use the MAX 485 interface module with Arduino and communicate with multiple controllers, so I highly recommend reading this article. We have 4 male headers on the data side. RO is the receiver output and it should be connected with the RX pin of the Arduino. RE is the receiver enable. This is active low. This pin should be connected with the Arduino's digital output pin. Drive low to enable receiver, high to enable driver. DE is the driver enable pin. This is active high and is typically jumpered to the RE pin. DI is the driver input and it should be connected with the TX pin of the Arduino. Similarly, we have 4 male headers on the output side. VCC pin should be connected with the Arduino's 5 volts. B and A pins should be connected with the B and A pins on the far end module. In our case, we will connect these with the B and A wires of the soil NPK sensor. Ground pin should be connected with the Arduino's ground. If you have never used the I2C supported OLED display module and the HC05 or HC06 Bluetooth module, then I highly recommend watch my Getting Started tutorials in which I have explained all the basics including technical specifications, interfacing and Arduino programming. I will provide links in the description. Now let's take a look at the circuit diagram. Let's start with the soil NPK sensor. As this sensor accepts a wide range of input voltages, so we decided to use a 12-volt power supply. This way we can use a single 12-volt power supply to power up the NPK sensor and the Arduino board. The black and blue wires of the NPK sensor are connected with the B and A pins of the RS485 TTL converter, while the VCC and ground pins are connected with the 5-volt and ground pins of the Arduino. The RO and DI pins are connected with the D2 and D3 pins of the Arduino. The RE and DE pins are connected with the D8 and D7 pins respectively. The HC05 Bluetooth module RX and TX pins are connected with the Arduino's TX and RX pins, and the power supply pins are connected with the Arduino's 5-volt and ground. The SSD1306 I2C supported OLED display module SDA and SCL pins are connected with the A4 and A5 pins, while the VCC and ground pins are connected with the 5-volt and ground pins of the Arduino Nano board. As we are planning to power up the Arduino board using a 12-volt power supply, so we will need to step down this voltage to 5 volts. So by using the 7805 voltage regulator, we can get regulated 5 volts. You can also see two decoupling capacitors are connected at the input and output sides of the voltage regulator. Now to power up the Arduino Nano, all you need is simply connect the output pin of the voltage regulator with the VN pin of the Arduino Nano. Next, we started off by interfacing all the components as per the circuit diagram already explained. The Android cell phone application used for monitoring the soil NPK sensor is designed in Android Studio. This is the same application I designed in my previous video, so I highly recommend watching this tutorial if in case you want to design your own Android cell phone application for monitoring different types of sensors, or else you can download the APK file. The purpose of this program is to read data from the soil NPK sensor and then display the values on the OLED display module, and also send the data to the Android cell phone application. For detailed explanation, read my article available on electronicclinic.com. I will provide a link in the description. We have already uploaded this program. Let's watch this project in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.